So we'll just start from where we left off. So yeah, so before break we were discussing about Playfair cipher. So in Playfair cipher, they just use a 5 by 5 matrix to construct letters by which it just encrypt the message. Then in the 5 by 5 matrix, they just take a keyword, then they just insert the keyword in your matrix and fill up the matrix with the remaining letters just in an alphabetic order. I guess up to this point you guys are clear. So there are 4 rules. In rule 1, whenever you see a pair of same alphabet, you are going to fill use another symbol or letter to fill up that thing. So here first pair is your L and L in the word balloon. So it just fill up the gap X. So there's another pair double O, but the thing is once you inserted X and it's a 2 letter combo diagram. So when you separate the whole word into two letter word, then it will be BALXLOON. So you can see none of these pairs or double letters are appearing together. Okay, so you just need to make sure that these pairs these pairs do not appear together. You no need to write your enrollment ID. Whenever you guys enter, I just take snapshot. In the end of the class, I always take snapshot of your class participants, so I'll get to know your names. Okay, no need to write your enrollment IDs. Okay, now it's the time for second rule. So what's the second rule? Two plain text letters that fall in the same row of the matrix are each replaced by the letter to the right, with the first element of the row circularly following the last. What does it mean? Suppose this is our main matrix, right? Our keyword is monarchy. After that, we filled up the matrix. So first letter is what? Uh, Plain text letter. Whenever we see letters, then we just replace with the letter right side of it. Okay. So let's just take an example like you want to replace this, for example, A and R. Okay. So how you are going to, this is your plain text. Okay, your plain text is a AR. We in this case we just take a diagram, right? It's a combination of 2 letters. So suppose you want to encrypt this AR word. So what's the first rule? You need to replace the item with the letter next to it. Correct? So what is the letter next to it? What will be the cipher? A next to it is R. So A will be replaced with R. Now see, R is your last item or it's in the last column. So what will you do? There is no right side, right? There is no right side letter. So it will go like your circular keyword, circular array. So after R, you are just going to consider the next alphabet from the word. So your R will be replaced by M. Okay, if your word is on in the plain text, then what will be your ciphertext? Ciphertext will be next to O is N and for on it's A. Okay, so moment when you get the word or letter in the last moment, it will go back to the first. So suppose your plain text is again Y and D. Okay, So what will be the ciphertext according to the first rule? Next to right side of Y is your B. Then it's D. D, there is no right side. That means it will go back to your first word in that particular row. So D will be replaced by C. Okay. So for YT, your plain text, ciphertext or encrypted text will be B and C. So this is your first rule. Okay. This is your rule 1. So what's the rule 1? You will just replace the text with the right side of your particular text. If it's A, then you will just check the right side text, which is R, and so on. Okay, so next is your third rule. Okay, this was your second rule. The first rule was you cannot keep anything in pair. You just need to fill up the pair. So third rule is what? Two plain text letters that fall in the same column are each replaced by the letter beneath. Okay, with the top element of the column circularly follow the last. So you can see that if you consider as a row, you will see the right side of that row, and if you consider it as column, then you will replace the letter with the column wise. That means it will be beneath. Okay. Okay, let's see the example again. So maybe three. Okay. Now your plain text maybe M and U. Okay. So what's happened here? What is M? M is here, correct? N is U is here, correct? So now you will see in terms of column. If in rule 2 you just consider in a row wise. Okay. Now you want to consider it as a column wise, right? So what will be the encrypted version of this? For M, the beneath word is your C. Let's take different 2, 3. Now we are going to take in a column MU. So your ciphertext will be M and it's C, right? So your M will be replaced with your C and U. There is nothing beneath U. So it will go back to your M again. Okay, so U will be replaced with what? M. Okay, so you can take another example. Maybe let's just take YW. Okay, I'm not getting it. Okay, I'm telling you again. So now it is plain text is YW and you are going to replace it with the help of rule 3, which is the replacement with, according to the column. So what will be the ciphertext? See, in the first rule 2, we checked, we went like a row. In the first row, we are just going to replace the with the letter which is right to the particular letter. So if you consider it like a column, there is no right. Column goes like this. So you are going to see the letter beneath the one. Okay. Yes. If Y, then below Y we have Z, G, and W. There is nothing beneath. It will go back to N. Correct. So it will be G. So if it goes row wise, you are going to take circular array, you can say. If you go column wise, again it's the same. In row, it will go from right side, okay, for the row. And if you consider column wise, of course it's a vertical one, right? You will go down there. So your row can be circular way. In a same row, when you reach the last position, you will go back to the first one. And in case of column, you will just consider the letters just below there. So once you reach the bottom, then it will go back to the top again. So rule 2 is for the row wise replacement, and rule 3 is for your column wise replacement. Okay, is it clear now? Okay. So let's see what's the fourth rule. Otherwise, what it does? Otherwise, each plain text letter in a pair is replaced by the letter that lies in its own row and the column occupied by other plain text. Now, there is the fourth rule. What it does, it's not going to check your row or column wise thingy. Okay. So mm, so what it will do, you can just think it as a suppose 0, 1, 2, 3, 4. You have a table. I'm just giving example. Okay, I'm just giving 0, 1, 2, 3, and 4. Okay, so we can take letter maybe equal to HS. H. Okay. Now, how we can replace it? H. See, what's the location of H? Okay, location of H is 1. H can N is your S. Where is your S? Okay. In this case, our letter is H and S. Correct? This is our plain text. So for the ciphertext, what it will do, it will just take the location. See, H, you will see the column of S. Okay, you just go upside. Okay, so what's the element here? For H, you are going to replace it with D, and for S, what's the same line? You are going to replace with T. Okay. So in fourth rule, what it does, it just see the location of your plain text. Okay. So based on the plain text, it's going to just consider the row and column for your next plain text. Okay. Here it is S. So this is our H. So what are the letters for S? For this column, for this column, for S column, we have these letters. Okay, for H, you can just think like this. So H is our plain text. Next is our S. So you will just point out the location of S and H. Then you will simply replace with the other word that is in the same row and column. So H and next word is S. So you will just go up. Okay. So if you go point like this, what's the letter? It's B. So you will replace C by P. Now for S, again you have the other letter which is A. So in that location, we have P. Okay. So S will be replaced by P. Okay. We can take another example. Plain text maybe E and A. Now what will be ciphertext? E and A. Where is your E? Color. E and A. This is our E, correct? And this is our A. Okay. So what you need to see, you are just going to consider this column for A and row for E. Okay. This one is too messy. Just come here. Okay. Our plain text is E and A. Correct. So using the rule 4, what we can do? See the locations again. For E and for the column A, what's in the same location? It's I and J. Correct. And for A, what's there? It's just M, and it's A. I'm just double circling it. Okay, double circling here. So what will be the answer? That means for E, we have two options. Either we can replace it with I, or we can replace it with J. Because ij I am counting it in this case is counted as 1. So here you have two options because A is in this location. So for this same particular row and column, we have two options I and J. So U, E, it can be replaced with either I or J. Now we have E. For A with the same row and column, the word will be M. So our A will be replaced with M. So depending means your wish, you can replace EA. This encrypted word can be either IM or JM. Yes, correct. It's I or JM. Correct. So in rule 2, rule 1 was what? If you see same pairs, you are just going to fill it up with other filling letters. Rule 2 second way, these are like different ways. Okay, in rule 2 it's a row wise. Okay, you are just going to replace the letter with the next right letter. Okay, if your letter is at the end position, end of row, then it can go back to the first position again. In the rule number 3, which is a column wise, what you are going to do, you will just replace the item which is done one beneath the particular letter. So if you reach the last column, then it can again go back to the first one. And in rule 4, the other one, what it does, neither it takes the row wise thing nor the column wise thing. What it checks the location of the plain text letters. And based on the plain text position, it's going to replace it with the other letters which is in the same row and column. So in this case of E and A, E and A, you just get the location first, then you map. Okay. For A column, you will reach this column at this point. So you can replace E by either I or J. Okay. And you can replace A. You will check the location of E again. From E, you will reach it using the M. So you can replace it with I and M. Ma'am, if I write M first, then I or J, then what will happen? If you write M first. If you want to write first, M first, that means your word have to be A and E. Correct. In this, M is the replacement for A. So if you want to make it MI, that means your A have to be in front. Then only A will be replaced by M. Are you getting my point? If I write M first. Yeah. In this case, what happened? HS. Okay. H is your plain text. Correct. This is your is H is your plain text and S. Where is your S? This is your S. Okay, S and H. So H can be replaced by in the same row. It's B. Correct? From S you can reach B. So H been replaced by B. Then S for same location P and is reachable. Right? So your S will be replaced by. So fourth rule is mainly based on the location of your plain text only. So if you want to make it PB, that means your plain text has to be SNH. Ma'am, can you explain the rule 1 with another example? Okay, rule 1 was what? The pair will be should not be together. Main point is any pair should not be together. Okay, balloon. What can be the other? Can be another word which has okay room. Okay, room is a word. So in case of room, we have a pair. Correct. So okay. So what it does, it is a diagram one, right? It's not replacement of one plain text with the other, but two. So you are going to refill it with other word. Okay, but in this case, it's not exactly same. It's your wish actually. Okay. In this case, if you separate, it will be again just RO and OM. Okay, this can be one way. Or if you want to put a filler, then if you want to put a filler, what will be RO X ROXOM. Okay, then your order will be RO, then XO, another pair. Now M is your lonely word. You can just put another symbol to fill up this thing. Okay. In case of balloon, what happened? You just took the first word, right? LL is together. So you just put a filler word in between L and X. So LX, one word, then LO, then ON. So these are already separated. They did not put any filler word between O because they already got separated. Hence, you just have to make sure that the words are not together. It should not be paired up like LL and OO. Okay, it shouldn't be like this. So just to make sure that you are going to place another filler word. In this case, there is no need actually because if you just divide one single word, it's already it's RO and OM. They are not in together. They are not combined together, right? So see, if your two words are together, then it will be very easy for the other people to get that these are the same word, right? Yeah. So if you make like same letters together, it will be easier to guess. That's why they just make sure pairs should not be together. So in this case, there's just one monarchy. You can try with the other letters. A keyword will depend on you. Okay. For example, you want to take a keyword lemon. Okay. Take lemon. Then you can construct your own matrix 5 by 5 matrix with the help of lemon. So lemon, what you can do, your matrix should be 5 by 5. So you are going to put lemon first, LAMON. So your first row is already filled up. So rest you will just go with like alphabetically. It will be A, B, C, D, E is already used. It will be F, G, H, I, and so on. Okay, just make sure that lemon, this LEMON should not come again. Okay, that's how you construct the matrix with the help of a keyword. So based on your keyword only, your matrix will be considered. Then after that, you can encrypt the message using these four rules. Okay. It can be a homework. You can try by your own. Everyone just take one keyword. Okay, and construct the matrix. Then you just encrypt your own message. Gonna try it? It will be a homework, of course, not now. Are you getting the process? How the Playfair cipher works? Is it clear to everyone? One said yes, two said yes. Okay, so if it's clear to everyone just try, just take one keyword according to you. You decide what keyword you want to use. So accordingly, you generate the matrix. Then you just encrypt any message. Okay, you can just take one line or two words. That's up to you. So this is your Playfair. This is relatively tough to decipher for the hackers to get the message, but still it's not impossible. Just like the monoalphabetic one, this case also your hackers or third party can detect your encrypted message with the help of your frequency of occurrence. So just like monoalphabetic, they can just check the occurrence relative frequency of your English letter text and your text occurring here. So depending on the frequency of occurrence of our letters, they can just guess the Playfair one as well. So this was is not also, of course, all of this cipher encryption process is secure, but nothing is impossible for the hackers, right? So next is your Hill cipher. What is Hill cipher? Hill cipher is basically like with it's given by a mathematician Lester Hill. So it's a multi-letter cipher. Remember the monoalphabetic and Caesar is a single alphabet. Your Playfair one was a multi-layer cipher too. In case of Playfair, they use combinations of two letters. So here can be again it can be different. So it's also a multi-letter cipher. So it's mainly based on your linear algebra. So if you want to use Hill cipher, you have to make sure you are good at matrix algebra, mainly based on matrix things. Okay. So what it does, it simply takes m successive plain text letters and substitutes for them m ciphertext letter. That means if there are m number of letters, means 5 letters, for the 5 plain text letter, there will be 5 ciphertext letter. And the substitution will be determined by m number of linear equations. And each of those equations will be characterized by assigning some numerical value. For example, you have alphabet. These are also based on your alphabets. So alphabets means we have 26 letters. So you can just give numbers to your alphabets. Like for A, 0. So index will go like 0 to Z, right? 0 to 25 or 26 letter. Okay. Okay, just take 5 minute break again. Okay, it's a 5 minute break. Are you guys back? This is the last one I'm going to teach for today. Okay. I just finish it faster. Okay. So this is the Hill cipher developed by a mathematician. So we use this Hill cipher way, encryption method, substitution method, and you need to know about your matrix multiplication, inverse, and all matrix related um, sums. Okay, so what it does, if you have n number of or m number of plain text, it will just convert it into m number of ciphertext. So first, what it does, it can just give some here. So it can just give certain numbers. We have alphabet 26 alphabets, of course. So you can number A equal to 0, B equal to 1, and so on. Ultimately, Z will be 25. These are the numerical values assigned to your alphabets. Now, your M, for example, your M is 3. M3 means you have 3 plain letters. So if you have 3 plain letters, then your ciphertext will also be a 3-letter word. So just for example, I'm considering here as m equal to 3. So your ciphertext will be like you need there will be a key. Now your key will be a matrix, and just think your key is a 3 by 3 matrix. Okay, so your key will be a 3 by 3 matrix. So if your m equal to 3, then your key will be 3 by 3 matrix. Then if your m is larger, then your key will again will be of same size. It has to be a same square matrix. Okay. So if k is your square matrix, 3 by 3, that means how many keywords will be there in a matrix 3 by 3? Okay. This meeting is going to end. I'm just ending it, then we join again. Okay, I just want to finish this one. Next class we'll discuss about two other different types. Okay, I'm ending the meeting. Just join it fast, then I'll finish it